Celestial bodies have been forming in the galaxy for over 20 billion years. Egyptians created the first solar lunar calendars as far back as 2000 BC. Galileo used telescopes to discover 4 Jovian moons, the moon's craters, and the Milky Way in the early 17th century. And today, you too can discover these stars, moons, and galaxies with your own eyes at the Cincinnati Observatory. See beyond this world at the Cincinnati Observatory.
This is what we call our new telescope, 1904. The original telescope, the Mers and Mahler telescope, is in the other building, but in 1873 it used to be situated right where this telescope was. Then when they acquired this telescope in 1904, they took the Mers and Mahler, put it into the small observatory building immediately east of here. Now in 1904, there was no electricity here. So the astronomers wanted a telescope to run mechanically to track the telescope across the sky to compensate for the Earth turning on the axis of rotation. It has a 16-inch diameter lens. It was estimated it took 18 months to hand grind that lens. There are 2 pieces of glass. And if you open up these little windows on the side of the cell that supports the glass, you can see that those 2 pieces of glass are separated by about 1.75 inches. And each of those 2 lenses was literally hand ground to within millionths of an inch accuracy in relation of one surface to another, all by hand. It was amazing the way they could do that process in those days. And they would hire a teenager to work for them. The teenager would get paid 25 cents a night to work all night for the astronomer. The teenager would have 3 jobs. The first job, they would be coming over here and using this modern device we call a bull rope and pulley. And by pulling down on this bull rope and pulley, we open up the shutter in the dome to let the view of the night sky come into the observatory. The second thing the teenager would have to do is add energy to the telescope. Now in the base of the pier, once I open this door here, you can see that there is a block of steel weighing 400 pounds here. And the teenager would use this crank to crank up the 400 pounds. And you can see the crank and the weight going up. And then gravity takes over, dropping the weight very, very slowly. Well, that's a form of energy, kinetic energy, a falling weight. And that energy is then transferred to the top of the pier, where there is a clockworks that moves the telescope very, very accurately. I'm going to open up the top door to the pier, and you can look in and see the clockworks move. And you can see a governor spinning at the top. The governor has vanes or paddles on it, moving in and out as the governor spins, governing the speed of the telescope. The energy or torque is then transferred to these 2 small gears on the side. You can see them move very slowly, but they are moving. Then the energy or torque is transferred up this long shaft on the outside to the top where the big gears are. It turns a few small gears, then the big 32-inch diameter gear. And that gear then turns the main shaft of the telescope. And the main shaft of the telescope is parallel to the tilt of the Earth's axis of rotation. So if you could look up the center line of the polar axle, you'd be looking out into space where the north celestial pole is, or the North Star Polaris. These telescopes are what we call equatorially mounted, and that's a term they use to describe this orientation, to move the telescope in only one direction along the polar axle. Now, we can move the telescope in various ways. One is you can just grab the telescope and move it back and forth and swing it. But the more traditional way is to grab these 2 big hand wheels. The top hand wheel moves the telescope in one direction, north and south. And I'm going to move the telescope to one of the extreme positions. And notice that the lens is now pointing to low in the northern horizon as though you're looking at a star. Now, if that were our target tonight, look where the eyepiece of the telescope is. It's above wall height. But wherever the eyepiece is, it is, and you need to get your eye up to the level of the eyepiece. Occasionally, the eyepiece will be down at floor level, other times above wall height. So how are we going to get you up to that height to look through the telescope? Behind the observatory telescope is a platform called an observing platform. It's a 1904 elevator. It's on wheels. We wheel it around to wherever the eyepiece of the telescope is positioned, walk up a flight of stairs, and then manually push this platform up or down until you get to the appropriate level. Then you lock the platform in place and then stand on a platform, typically in a darkened room because they do observing in a black observatory late at night. Now, we mentioned the teenage volunteer had 3 jobs. The first job was open up the shutter. The second job was to turn the crank to add energy to the telescope. But the third job was the hardest job, and that was to turn the dome. Because you had to turn the dome to keep the shutter in line with the object as the object appears to drift across the sky or to go to a new object. There was no electricity here, no motors to turn the dome. So the teenager would use a big old hand wheel over here on the west side of the telescope. We're going to take a walk over there and watch what happens when I use this wheel. I'm just using fingertip pressure, 2 fingers, and once the thing gets rolling, 1 finger will actually do the job. It's so well balanced. Before they added the dome, which was done in 1893, they had a wooden structure here, and that structure would rotate on big old ball bearings, and they used Civil War cannonballs for the ball bearings. Now let's go back to the telescope. And occasionally we want to look at things in different sections of the sky. So the telescope is now positioned on the east side of the pier, and that's a good position if you want to look at something in the west in the sky. But what do you have to do if you want to look at something in the eastern sky, such as the planet Saturn rising, perhaps? Well, then you have to take this telescope and then move the telescope to the west side of the pier, and they call that flipping a telescope. So to flip the telescope, you go through this method of movement. You park the telescope so it's approximately parallel to the main axle. Then you grab the bottom hand wheel, and you put a lot of weight into the bottom hand wheel to twist it. Then the whole telescope literally flips over to the top of the whole telescope mount, all 100% mechanical, no electrical. And that's the way the old astronomers then would use the telescopes. Now, you'd probably want to look through the telescope. Everybody wants to look through the telescope, but more often than not, it's daytime when we're doing this history tour, and there's nothing to see in the daytime sky with this telescope. But we can simulate the telescope viewing. We're going to bring the lens end down to the floor and let you look up into the telescope backwards. Have you ever had a chance to look through a telescope backwards? We'll take the dust cover off and then shine a bright light up the telescope so you can see the inside of a telescope. It's a 22-foot long tube, and that little bit of brass you see way at the top end of the tube is the back end of the eyepiece that you normally would look through. So that's a brief tour of the Cincinnati Observatory, the 1904 Alvin Clark telescope, and we thank you for visiting the observatory.